We are moving on to chapter 7. This is 7.1. And 7.1 deals with what we call sequences and series. And sequences are lists of numbers that are ordered. So there's like a first number and a second number. And those sequences change according to a specific pattern. Now, there are tons of different sequences out there. We are only going to study two. And hopefully you've heard of these before. The first is, now I know that says arithmetic, but we say it is an arithmetic sequence. And all arithmetic sequences are either an addition sequence or a subtraction sequence. They're sort of the most basic sequences out there. So if I had 4, 6, 8, 10, and a sequence can go and stop, or the sequence can just go on forever. Okay. Now, every term in a sequence has a name. So if this sequence was, say, sequence C, then the first term in the sequence would be C with a little 1 next to it, and we pronounce that C sub 1. The second one would be C sub 2, and C sub 3, and then so on. So a sequence has an order and a pattern. Okay. Now another sequence might be like D, which could be 10, 9, 8, 7, and so on. Okay. Hey, Raina, if you can't pay attention, go back to your seat. Yeah, go over there. Pay attention. All right. The other type of sequence, do you guys remember? Geometric. Good. Geometric sequences have what pattern? Multiplication, right. So we could have sequence A, which is 2, 6, 18, and so on. Okay. Now, all geometric sequences are described using multiplication. So arithmetic sequences can be described using addition or subtraction. And you would think that a geometric sequence would be multiplication or division. But we don't ever use division. We always just use multiplication. It makes the formula a little bit easier to use. Makes it a little bit confusing sometimes, but how could we do a geometric sequence that shrinks instead of grows? So we're not allowed to divide. We multiply by a fraction. So if I had something like 625, and then 125, and then 25, and then 5, and then 1/5, or sorry, 1, and 1/5, and so on. So you might think the pattern here is divide by 2, or how about 5? And that is true. You can create this pattern by dividing by 5, but we never divide with geometric sequences. So we say the pattern is multiply by 1/5. And we do that because division can kind of make it easy to make a mistake inside our formulas as we study geometric sequences. Okay, is that all reviewed to you guys? All right, let's move on to 7.1. So find the first 4 terms of the sequence given by the following. So this says the sequence is 33 plus 3 times n minus 1. And our n is going to start with 1 and 2 and 3. So how do we find a sub 1? I plug 1 in. So we stick in a 1 there, and I get 0. 3 times 0 is 0. So term 1 is 33. Okay, now a sub 2. Plug in 2. 2 minus 1 is 1. 3 times 1 is 3. 33 plus 3 is 36. Now we plug in 3. 3 minus 1 is 2. 3 times 2 is 6. 33 plus 6 is 39. Does that make sense? Okay. This is a geometric sequence. Actually, this is not a geometric sequence. So same idea. We need to plug in 1. So I stick a 1 here, and I get 1 plus 1 is 2. And what is negative 1 to the second power? Positive 1. So essentially, this just goes away. And then I plug 1 in there. 2 times 1 squared is just 2. Okay, now we plug in 2. If I stick a 2 there, what is negative 1 to the third? So it'll be negative 1 times negative 1 times negative 1. It'll be negative 1. And so we plug in a 2 here, and I get 2 times 4, which is 8, but I have to hit it with the negative 1, so negative 8. Now we do 3. Put a 3 there, and I get negative 1 to the fourth. What? Negative 1 times negative 1 times negative 1 times negative 1 is positive 1. Then I put a 4 here, and I get 16 times 2, which is 32, and so on. Okay, easy enough? All right, this is a geometric sequence, and it wants us to plug in 1. So we stick a 1 there. 1 minus 1 is 0. And 4 to the 0 is not 0, 1. So 5 times 1 is 5. Plug in a 2. 2 minus 1 is 1. 4 to the first is 4. And 5 times 4 is 20. And then you just keep going. All right, and I believe this is the last problem. So this is kind of a sequence built with a picture. So the first picture has 6 blocks, the second picture has 9, and the third picture has 12. Can you see the change between each picture? What is the change between one picture and the next? It gets bigger. In which direction? Plus 3 on in the width. Well, sorry. So we add 1 column in the width, which adds an additional 3 blocks. Whether it's on the left or the right doesn't really matter. So if the first has 6 and the second has 9 and the third has 12, how many will figure 4 have? 15. We add another column, and that column contains 3 blocks. So it will be 15. Okay, that's it for 7.1. Get to work.